So CurvaFix allows you to fill curved corridors and provide strong fixation. So it's I would say one of the few implants that's actually adaptive to the individual patient's anatomy and allows for safe passage. It does allow for early weight bearing, and I actually haven't had any of them back out. It's been kind of an interesting journey in using it because I have personally noticed a difference. So the adaptive design, somebody mentioned we had a kind of information meeting last night about some research that we're doing. And one of the things that we don't want to miss is kind of having everybody understand the design of it and how it makes it a rigid implant after you get it in. And so basically there's a 7.5 and 9.5 millimeter diameter option. The interlocking components, as you can see, is from basically how the metallic components are, and then the internal compression device that you can see partially here, and I'll show you some other parts of it that make it a rigid implant once you get it in. But there's a self-tapping design for the threads and the front cutting end, and then it's a stainless steel device. And there have been some removals, including a couple of broken ones, but the removal process hasn't been a significant problem. I've taken one out, and the cables kind of stayed together to get it out. But this is how it becomes a rigid implant. So there's 4 cables that are similar length, and then when you become in the rigid state, when you lock it, the cables provide compression. And one of the things that you have to get used to is actually the implant will get some compression in that fashion. So it will shorten up some as you compress it to lock it. But this is just a diagram showing some of the, flexibility in the design. And that's one of the things that kind of made me think about using it, is getting around implants that are indwelling already, especially in the sacrum. But it allows you to have a little bit more freedom for your starting point as well. So compared to straight versus curved implants, obviously if you're using a straight rigid implant, you're not as flexible or have as many options as something that curves and follows the corridor, basically. And so there has been some biomechanical data that shows that the pullout strength is significantly higher than both 6.5 and 7.3 millimeter cannulated screws. And you could see, 715 newtons versus the closest one is 503. So just some updates and some kind of background. So it was designed by Dr. Meek, who's actually here, if you want to talk to him afterwards, to get his thoughts and why he thought it was important to kind of bring this to fruition. It's been in use since 2019. There's over 125 surgeons using it currently, and I'm sure that's going to add as the time goes on for sure. It's used in over 85 facilities. And we are kind of looking at trying to get safety and efficacy data, especially in geriatric pelvic fractures. And so if you have any interest, if you start using the implant and want to contribute to both a prospective and there's a retrospective arm of the study as well, please contact me. Obviously, you can get me through the OTA or just come up to me afterwards. So to date, the implant breakage is 0.3%, 1.3% for removal and revision, loss of fixation 0.3%, removal or revision due to loss of fixation 0.3%. So all of these are very low. Longest time to implant removal is 2 years. So that's a pretty long time. It's not like you're taking these out at a year if you're going to take them out, or at least that's what's been done. And typically in geriatric patients, I don't take them out. I just leave them in.